All right, we're going to continue with divisibility rules. This time the numbers are getting a little bit bigger. Now we have 3 digits. I'm going to do like 1 for you for practice, and I'm going to do it all the way across, and then you can practice however many you feel like you need to before you feel like you've gotten this. All right, so I'm going to do 345. Is it divisible by 2? And the answer is no, because it does not end in a 0, 2, 4, 6, or 8. Is it divisible by 3? Is the sum of the digits a multiple of 3? 3 plus 4 is 7, plus 5 is 12, and 12 is a multiple of 3 because 3 times 4 is 12. So yes, it is divisible by 3. Is it divisible by 4? Well, the number formed by the last 2 digits, it's 45. Is 45 a multiple of 4? And no, it is not. Divisibility by 5, if it is either a 0 or a 5, the last digit, then it's divisible by 5. So it's a 5. Is it divisible by 5? Yes, it is. Is it divisible by 6? Well, to be divisible by 6, it has to be divisible by both 2 and 3. So it is not divisible by 6 because it's not divisible by both 2 and 3. All right, the doozy. Is it divisible by 7? Double the last digit. 5 times 2 is 10. Keep that in mind. Subtracted from the number formed by the rest of the digits. The number formed by the rest of the digits 3 and 4. 3 plus 4 is 7. 7 minus the 10 is a negative 3. Negative 3 is not a 0 or multiple of 7. So this is not divisible by 7. Okay, I think I need to go back and clarify something because I want you guys to make sure that you get this. All right, up here on the divisibility by 7, yeah, take 5 and double it. That's 10. Okay, but here you don't add the digits together. You just look at the number formed by the rest of the digits. So the number formed by the rest of the digits is 34. 34 minus the 10 is 24. 24 is not a multiple of 7, and it's not a 0. So number formed by the rest of the digits is 0. Nope. Number formed by the rest of the digits is a multiple of 7. Also no. So no. Okay. But let's go down here and just make sure on the number on divisibility by 7. Take the last digit 8 and double it. Doubling it is 16. Okay. Then take the number formed by the rest of the digits. The rest of the digits, the number formed is 16. 16 minus the 16 does give you a 0 or a multiple of 7. It gives you the 0. So yes, it qualifies. 168, for instance, would be divisible by 7. So that one's a little tricky. You got to kind of be on your toes for that one. Okay, let's go back up here and resume. 8. Again, we have to read these directions carefully. If the number formed by the last 3 digits, well, I mean, the number is only 3 digits. If the number formed by the last 3 digits is a multiple of 8. So when you memorized your multiplication tables, you really only went up through 12 times 12. So the biggest multiple of 8 that you probably learned was 8 times 12, which is 96. And so you're still like, well, I don't know if 345 is divisible by 8 or not. So you may have to kind of just divide it out and see, because you don't know if 345 is divisible by 8 because you're looking at all 3 of those digits, and it's bigger than those things that you would have memorized with multiplication tables. However, I'm going to give you a hint. 345, I know, is not divisible by 8 because I know that anything that's divisible by 8 has to be an even number. Okay, I can't think of any number that's an odd number that's divisible by 8. Okay, so I know that this is not going to be divisible by 8. I can sit there and divide it out too. I mean, I can sit up here and do 345 divided by 8. 8 times 4 is 32. and you get a 2, and you carry down a 5, and 8 times 3 is 24, and you get a remainder, so you're going to have a decimal. But anyway, so this one's a little bit big to just be like, yeah, I know it is or isn't, but it's an odd number. So no, it is not divisible by 8. All right. If the sum of the digits is a multiple of 9, all right, 3 plus 4 is 7. Remember now it says sum of the digits, so I'm adding the digits. 3 plus 4 is 7 plus 5 is 12. 12 is not a multiple of 9. And then it's also not divisible by 10 because it does not end in a 0. All right, we're going to flip and do a 4-digit number using the same rules. All right, we'll do this one, 3,912. It is divisible by 2 because it's an even number. It ends in 0, 2, 4, 6, or 8, so we'll put a yes. Is it divisible by 3? I don't know. Is the sum of the digits a multiple of 3? 3 plus 9 is 12, 13, 14, 15. 15 is a multiple of 3. So yes. And because it's because it is divisible by both 2 and 3, it's also going to be divisible by 6. All right, so let's do 4. If the number formed by the last 2 digits, there's the number formed by the last 2 digits. 12 is the number formed by the last 2 digits. If that number is a multiple of 4, and it is because 4 times 3 is 12. So yes, it's divisible by 12. Sorry, yes, it's divisible by 4. Okay, does it end in a 0 or a 5? No, so it is not divisible by 5. All right, then we get to 7. The fun one. If you double the last digit is 2. Double that and you get 4. Okay. If you double the last digit and subtract from the number formed by the rest of the digits, okay, 391 minus 4 is going to be 387. And unfortunately, this number is big enough that I don't know my multiples of 7 all the way up into the 300s, so you may just have to come up here and divide it out and see, okay? All right, if the number formed by the last 3 digits is a multiple of 8. Again, I don't know my multiples of 8 all the way up into the 900s, so you may just have to divide it out and see. If the sum of the digits is a multiple of 9. Again, not super helpful because we have 4 digits, okay? But this one is the sum of the digits, so this one should be a little bit easier than 8. 3 plus 9 is 12, 13, 14, 15. 15 is not a multiple of 9, so that's going to be a no. It does not end in 0, so this last one is also going to be a no. So honestly, this one's a bit of a pain. This one's a bit of a pain because, you know, if you're looking at the last 3 digits, that's lovely and everything. But again, I don't know my 8 multiples all the way up into the 900. So you're probably just going to have to divide it out. Okay, and then I get to the next page, which is asking you to list all factors for each number. Like, what are all of the possible whole numbers that this particular number could be divisible by? Well, we'll start with the easy ones. It's divisible by 1 and itself. So it's divisible by 1. It's also divisible by 169. But what else is it divisible by? And the answer is, I don't know. It's not divisible by 2 because it's an odd number. Could it be divisible by 3? I don't know. Is the sum of the digits a multiple of 3? 1 plus 6 is 7. 7 plus 9 is 16. And last time I checked, 16 is not a multiple of 3. Okay, so we're out of luck with 3. We're probably going to be out of luck with 4 because, again, kind of like 8. If something's divisible by 4, it's probably going to wind up being an even number. But let's go ahead and test it. If the number formed by the last two digits, which is 69, would be the number formed by the last two digits, 69, is that a multiple of 4? Well, I know 4 times 12 is 48. 4 times 13 would be 52, and then 56, and then 60, and then 64, and then 68. So nope. Okay. It's not divisible by 5. It's not divisible by 6 because remember it wasn't divisible by 2 or 3. If you double the last digit subtracted from the number formed by the rest of the digits is 0 or a multiple of 7. Okay, so let's see. Take your last digit, 9, double it. It's now 18. Take 18 from the number formed by the rest of the digits. 16 minus 18 is a negative 2, and that's not 0 or a multiple 7, so it's not divisible by 7 either. So you're kind of like, golly, is it divisible by anything? Yes, but we're going to have to do a little bit of work to figure that out. Is it a multiple of 8? Well, again, 8 times 12 is 96. But if you are doing multiples of 8, you're going to wind up with a bunch of even numbers. So you're not going to have an odd number that's a multiple of 8. So that's not going to be a multiple of 8. Let's check 9. If the sum of the digits is a multiple of 9, 1 plus 6 is 7. 7 plus 9 is 16. 16 is not a multiple of 9. It's also not a multiple of 10. So now you're kind of like, what on earth do I do? Okay, well, this one, it's a little hard, but so it's not divisible by 10. Let's keep going. Is it divisible by 11? I don't know. Divide it out. Is it divisible by 12? Probably not, because if something's divisible by 12, you're going to wind up with an even number because you're dividing it by an even number. So it now gets you to the final answer. Is this divisible by the next biggest number, which is 13? And it just so happens, and this is me knowing and you guys not knowing, 169 is divisible by 13 because 13 times 13 actually happens to be 169. But you wouldn't know that off the top of your head because when you learned multiplication tables, you probably only went up to 12 times 12. But 13 times 13 is 169. So that is the other factor. Okay. So is life always cut and dried and neat? No, not necessarily. All right, but let's do an easier one. First of all, the two easy ones. 102 is divisible by 1. 102 is divisible by 102. I can tell very quickly that 102 is also divisible by 2 because it's even. All right, well, 2 times what would give me 102? So 2 times 51 would give me 102. All right, so I've got 1, 102, 2, 51. Let's see. Is the sum of the digits divisible? Is the sum of the digits a multiple of 3? 1 plus 0 plus 2 is 3, and 3 is a multiple of 3. So this is going to be divisible by 3. I just don't know exactly what the other number, 3 times what, gives me 102. Well, come up here, do 102 divided by 3. I know that 3 times 33 is going to be 99, so this is probably 3 times 34 is going to give me 102. Okay? It's not going to be divisible by 5. It will be divisible by 6 because it was divisible by both 2 and 3. So 102 divided by 6, I don't know, maybe, maybe 16. But anyway, take 102 up here and just do divided by 6 and figure out what you get. It's not going to be divisible by 7, I can already tell, because 10 minus twice this, 10 minus 4 is 6. It's not going to be a multiple. It's not going to be a multiple of 8 either. I know that 8 times 12 is 96. 8 times 13 would be 104, so out of luck on 8. Sum of the digits is a multiple of 9. Nope, because the sum of the digits is only 3. And then is the last digit a 0? No.